Welcome to Simcast, a podcast brought to you by the Society for Imaging Informatics and Medicine. This episode of Simcast features the first of two conversations on the history of VNA. Ever wonder about the origin of VNA? What about following up on whether VNAs present an effective solution for storage? In this episode, hosts Prasanth and Mohannad are joined by our guests, Greg Strowig, Ken Persons, and Brian Willaert, for a thorough discussion on all things VNA. Greg currently serves as Vice President of R&D for Medical Informatics Product Development at Fujifilm Healthcare Americas Corporation. Ken serves as an Enterprise Imaging Architect at Mayo Clinic in Rochester, Minnesota. Brian also works at Mayo Clinic, primarily as a team lead in the Mayo Image Management Systems IT team, recently moving into a role as the Technology Manager of the Radiology Department IT team. Sit back, relax, and enjoy this episode of Simcast.
So VNAs have become a commonplace storage device, but kind of wondering, where did the idea come from in the first place? And more importantly, what was a problem that was trying to be solved, and did it actually get solved? Ken, you want to kick this off?
Sure, I can go back. So we're going back in time now, getting in the time capsule, and we're back in the late 1990s. And what was happening back then is the world of film was just on the verge of going digital. For those consumers that had cameras, and we used to take 35 millimeter film, the Kodak film and stuff like that. The first digital cameras were out. They weren't very good yet. But in the medical world, the diagnostic systems were, starting to go digital as well. There were solutions that could take the digital images from the medical devices, the scanners, and provide a way to view them. And so there was at the time, people will be familiar, that's when PACS was being born as well. There were early PACS systems that were around. They were proprietary, and they were trying to solve the problem of dealing with this digital data and providing the tools to view the digital data and interact with it in a way that was similar to what radiologists at the time were familiar with on board, backlit boards where they could go through their motor through their images and compare it and so forth. So there was no concept of a VNA yet, but what was apparent was to us here, at least at Mayo, was there were lots of areas that were converting to digital. Radiology was certainly one, and they were, embracing PACS to a certain extent. They were expensive, but there were other areas that also took images, especially photography, dermatology being a big one. And there was no place for them to put the images. Most of the departments had places that they stored their slides. I remember big cabinets with drawers and filing systems and labeling systems and lots of human labor. And there was no answer for them. How do they go digital? What do they do with all this stuff? Where do we store this stuff? So the question that was raised was, okay, we need a plan. We see that the world is going digital. We need a place to put this digital data. The idea was an archive, I guess, and PACS provided an archive for radiology, for the subset of radiology that was coming into it, but certainly didn't provide an archive for all the other stuff, even an archive for the complete radiology environment. So we kind of looked at the landscape and said, there are three things that seem to be needed at this time to prepare for the future. One is an archive that obeys standards, lives and breathes by standards so that anybody can use it as long as they work with standards. The second thing that was needed was a way to deal with photographs. Many areas created photographs for different things. And how do we take their data and put them into this archive, digitize them, associate them with the right patient so we know, find them, search for them, and view them. So there needs to be a way to view the data that's in the archive. That was another part, but also a way to index the content that goes into the archive so that you can search for it and find it by department or by patient and whatever. So those were the three big things that needed to be produced. The archive, a digital archive, standards-based, an index of everything in the archive with a viewer that can search that index and view the content, and a way to take photographs and where they're collected at the various departments, medical departments, and allow them to ingest those photographs in a digital format associating with the patient, putting them into the archive, in the index, making them viewable. So that was the road we headed down. There was no name vendor neutral archive yet, but at that time, Mayo looked to build the archive, and out of that was born a company called Terra Medica, for which I was there when Greg came to be interviewed as an employee, for one of the early employees for Terra Medica, to build the archive. That was going to be the product. The company was established, Terra Medica, to build the archive product. It wasn't called a vendor neutral archive yet. It was really a standards-based archive that could work, obey the DICOM, command structures and the DICOM data formats, understand them, and be that environment where we could start to build on for the imaging sources and consumers to start using for storing and retrieving that digital data that we were seeing was going to come in big waves in the near future. So that's the early history. Greg, I don't know if you want to add to that because you saw it a lot.
Sure. Thanks, Ken. Yeah, I think, from the vendor perspective, when we got started, we were working closely with the Mayo Clinic, of course. And as Ken said, there was no product category that we could really fit in. And we quickly found out when we started talking with other prospective customers, other health systems, there was a lot of confusion as to what we were. People thought our software was a PACS. Then they thought that we were actually a storage device that they would install and it would capture all the data. And so they're going to pay for that storage device in place of PACS storage devices. But really, we had to think about how we would differentiate ourselves from all of these things and create the need for our product, of course, because Mayo is very forward-thinking. There were other forward-thinking organizations in the country for sure. The University of Alabama had gotten started with a project, and Imagion had been born before Terra Medica. Imagion subsequently merged with a company called Ultravisual and became a PACS. And then that became part of Merge, then IBM and so forth. Terra Medica was founded in 2001 as the idea had been spun out from Mayo. And we really tried to focus in on the standards aspect to try to alleviate that concern that customers had about proprietary data that couldn't interoperate with other systems. DICOM had been around for a while, but everybody's flavor of DICOM was different. So could things be standardized? Customers were also dealing with PACS vendors who sold everything from the PACS software to the infrastructure as a complete kit and used the shield of the FDA and saying it was an FDA regulated system to prevent the customers from, for instance, purchasing their own storage. And at that time, storage was much more costly per terabyte than it is today. Of course, the amount of images today and the depth of those images is much greater today. But they were prevented from buying their own storage. And they wanted to standardize their storage according to the IT standards they had in their shop. They felt they could get a better deal than what they were paying the PACS vendors for. And so we, again, gave them the opportunity to buy software that could operate on whatever storage infrastructure they chose. I also think that the fact that radiology's infrastructure needs in a hospital were growing exponentially every year in terms of the cost, storage costs. They were changing out their PACS every 3-4 years. That was about the average turnover of a PACS system in the early 2000s. And therefore, they needed to migrate the data from the old system to the new system. And that was a huge cost to these health systems, is to move that data. There's also a lot of risk in moving that data for data loss and having challenges between vendors in terms of what one vendor's DICOM looked like to another vendor's DICOM. And radiology was just frankly using a lot of IT resources and monetary resources of the hospital. So they got a lot more attention from IT, and things quickly switched from being purely radiology governed to having a lot more IT governance. So that became our target, was IT, and to really target these issues of lock-in and creating that independence, that separation, the abstraction of data from the departmental workflow systems, which was the PACS, whether it's cardiology PACS or radiology PACS. Those systems could continue to operate. You could change those, sort of plug and play as you saw fit. Every 3 to 4 years, you could swap out those systems as you saw fit, or even on the back end, the storage infrastructure. If you preferred one vendor storage for a few years and then you had obsolescence and you had to go to another brand or denser storage, you could do that. And the VNA would essentially abstract all of that change from the end users. So that's really, how we saw our place in the market until things became defined as a VNA, which was probably in the late 2008, 2009 timeframe. It's not necessarily an acronym or a term that we really appreciated, because of archive sounded very, very dumb and sort of static, back-end cold storage, whereas we felt the VNA provided a lot more interoperability and was an active repository. But we accepted the fact that people chose to give us a product category in the end, because that gave a point of reference to all of the prospective customers. So at that point, there were a lot of independent VNA companies that had stepped in. A lot of these had come from either a DICOM router background or a data conversion, a data migration background. There were some pure play companies, like I mentioned, Imagion or ourselves at Terra Medica, that had started out with the mission of creating something that then became known as a VNA. And now customers could get their arms around the fact that there was a new product category. It was a software product, and what it could do. It generally had some defined value points that people knew about and could accept, and didn't get confused as to whether it was PACS or storage device.
Thank you both for the detailed answer.
So I just have one thing to what Greg said, and that's the VNA term. I know that's a question coming up in your list here. And I agree with Greg. I didn't like the term when it first came out. Vendor neutral archive. What the heck? I have since grown to appreciate it, because it's become an acronym like, Xerox did many years ago. You're going to go Xerox the thing. But the whole idea in the beginning was interoperability. And that's what the DICOM standard is about, is interoperability. It's the idea that you can standardize the way the data is formatted, and you can standardize the way the data is interacted with. And then systems can interoperate with each other. And to me, the medical imaging landscape is ripe for needing interoperability. There are many environments that make up medical imaging of the different types of sources, consumers, and that's only continued to evolve. More recently with AI's desire to get in the mix and process the data and produce other kinds of results. So the DICOM standard has been a welcome friend along this whole journey, and really a facilitator to make this happen. So in a way, the vendor neutral archive is really a standards-based archive that conforms to the DICOM standard and other standards as pieces and parts of it have been built. But that's what makes it vendor neutral, really. And I have to comment too on one thing Greg said that I totally agree with, and that's the word archive, which I think still today causes some confusion, because when people hear VNA, vendor neutral archive, well, it's an archive, right? It's just an archive. It's where you store the data and retrieve it from. It's an archive. It's storage. And it's much more than that. And I think maybe over the course of this discussion, we'll talk about what that more is and how that more evolved over time, because I think in the early days, it was more focused on providing a way to archive and retrieve the data, but it has grown in terms of the VNA, that is, has grown in terms of its capabilities to provide a number of other services, which probably have moved it at the borders of standards. Some of them are non-standards in terms of how the services are provided, but they're critical. And that pushes the standard itself, I think, to evolve to accommodate the needs that have been, coming around in terms of managing the data that's in the VNA. So I'll stop with that. That's probably enough background on the early history.
Thank you for that. Brian, did you want to add anything?
Yeah, I guess as I was listening to the other comments, Greg mentioned that the VNA is really, again, getting away from that term of archive, that it's not just some storage where you're storing your images to hopefully go get them later, that it is really more of that active repository, really the source of your imaging data in your healthcare system, that all of those departmental systems, they only need to keep those very recent exams for, like, whether they keep a month worth or if they keep a couple months worth, that they're able to really focus on those exams that are happening now and then pulling in the compares, and they don't have to spend the money on the storage to be able to keep everything for a year or 2 years or any more than just those recent exams and then the relevant compares. As far as performing as that active repository, that every day those departmental systems are able to purge off their exams that they worked on yesterday or last week or last month, and they're able to go to the repository to pull in whatever exams are needed in their departmental system, whether it's on a prefetch, like on an overnight type of process that's automated, or whether it's a just-in-time pull of those exams from VNA to pull it into their workflows. One of the other things, I'm sure some of the other questions will get to this, but so there's obviously the function of storing the images as they all flow into the VNA and storing them and indexing them to keep them so we know what's a radiology image, what's a cardiology echo image, what's a dermatology photo, what's an ophthalmology image that just came in. So indexing everything so that we can keep everything separated, at least within the software, not necessarily separated on the storage, because the software handles keeping those things indexed and retrievable by those fields. And then being able to really create those views of the data. So if there's a departmental system that wants to see, for whatever reason, they might want to see radiology images and OB images, the VNA can provide that view of the data that allows that departmental system to see the radiology images, the OB, but they don't see the cardiology, they don't see the dermatology, because that departmental system doesn't really need that data. And so controlling that access and filtering the data.
Thank you. Again, I appreciate you going to the details here. I do want to take one step back just for a moment. So in case we have anybody listening here, they're relatively new to the domain, it can sometimes get a little hard to distinguish how a VNA is different than PACS. Those of us who have been around for a while, we kind of know the difference. So for anybody that's uninitiated or new to medical imaging, how is it different from PACS, or how is it even different from just going out and buying a really big, expensive RAID array or even a clinical data warehouse? Greg, maybe we can start with you.
Sure. Well, a PACS traditionally today still performs a function for a specific department. It's a software that allows a workflow to be created, or many workflows to be created, to solve the diagnostic needs of that department. So in radiology, it contains a work list or many work lists that radiologists work from that tell them what they need to do next in terms of reading the patient studies. And then it provides a very high quality diagnostic viewing piece of software with tools and capabilities that a radiologist needs to not only go through the images, mark up the images, but also dictate the results of their report. And then there's a similar type of system in cardiology that allows cardiologists to do the same type of activity, although their workflow is very different. So there's PACS systems for ophthalmology, endoscopy, etc. And each one of these departments have different needs and workflows and viewing tools that they have to have. Some deal with video, some deal with still images, some deal with both. But in the end, the archival or the storage management of that data can be segregated and separated into a platform that is independent of these workflow and diagnostic tool sets. And that's really where the VNA comes into play. It creates that backbone across the entire enterprise so that many health systems today, they go through a lot of acquisitions and they have many different PACS vendors. Even in the same department, they might have 3 different radiology PACS vendors across their health system or more. So a VNA can be installed to provide that interoperability and storage management across all of those PACS vendors without having to keep that data inside each one of those PACS systems and sort of captive to that PACS system. So it allows the interoperability of this data. It allows the abstraction of the data out of the PACS and into a separate layer that then can be managed and have its own life cycle, its own rules. So we like to say that the VNA is the A in the acronym of PACS, but it also provides, VNA also provides additional capabilities outside of those departments that have traditionally had PACS. So PACS-less departments, such as, what Brian mentioned, dermatology. A lot of dermatology photos are just handled with a 35 millimeter camera. And they don't really have a true PACS system in many cases, or they didn't. Maybe there's some things that are coming around now that are more prevalent. But the VNA can handle that content. It can handle content from all across the enterprise, whether that department has a PACS or doesn't have a PACS. That's how I would kind of differentiate it. It's really an enterprise cross-departmental repository that creates an independent layer of data and interoperability and management.
Yeah. And I would just add a couple things to that. If you go back again, since this is a history talk, and go to the history of PACS, PACS grew up in the early days, 1980s. So they were first experimenting with some PACS, and really the 90s is when it started to gain traction and we started to see them showing up in medical centers. But it was really aimed at solving the problem that in those days, computer systems, the memory limitations, the operating system limitations, really made it difficult. You needed specialized hardware in order to handle these images and buffer them in memory and display them. The PACS Picture Archive Communication System, that collection of things, worked together initially in a proprietary way to manage those images and provide that ecosystem for that environment, radiology environment, or just the CRs in radiology, and the workflows in that environment, as Greg said. So, and really PACS grew up, I think, initially in radiology with cardiology right behind. But as it matured and as the standards matured, PACS itself became a standards-based solution. As we all know, every PACS today obeys DICOM, listens to DICOM, conforms to DICOM very nicely. And the data sets inside, can be retrieved or stored in DICOM format so that it plugs and plays nicely. But its workflow, its basic tenets on which the PACS is built and orchestrated are around certain workflows. So you really can see this in spades when you look at digital pathology. So pathology is just on the verge of going digital in a big way in the United States. I think the next 10 years we'll see it completely convert over. And they have a completely different workflow than radiology or cardiology or dermatology. But you know what? They produce digital data, and it can be put in DICOM format and it can be interacted with DICOM protocols, and it can be married up with other DICOM data that goes with that pathology data, like the radiology scan that caused them to get the sample taken out to be analyzed and so forth. So the VNA provides a beautiful way to orchestrate that data and, index it, coordinate it, and allow different tool sets, packs, whatever you want to call them, in environments to plug and play and provide the tools within that departmental workflow to accommodate the workflow of the collection of the data, the viewing of the data. I think the VNA has really positioned us well for AI as we move into that, where data is going to be consumed as part of workflows now, and AI results injected into the workflows, as well as consuming the data for learning and teaching AI, deep learning systems. So, I guess if you go back in the early days, the reason we headed off down the road of creating a VNA was a place to put all this digital data and organize it and view it. But as time has gone along, the fact that we did organize things that way and create that is really serving us well to accommodate new ologies like pathology, digital pathology, and the AI world that's sort of growing up that wants to consume and use the data in new ways, as well as, our whole virtual world has everything is getting virtualized, where you can provide services remotely, wanting to share images across medical environments. I think the VNA really positioned us well. One last thing I'll say about PACS VNA differences that we became painfully aware of is that at our environment, in radiology alone, we had 9 different PACS systems, and each PACS had its own risks, integration, and each one of those was using the VNA for storing its data. So we really, in a lot of ways, have built the integration level you think that you'd want, or like Greg described, but none of those PACS could see the data from the other PACS. So we still had patients carrying CDs between our hospitals and clinics and ingesting them, even though we had the data in the VNA. So I think that's a complex thing to understand. But I think we've evolved now in the VNA to a single view of the data, no matter where you are. The VNA has helped us do that with searching by a single patient ID to see all the data and retrieving it back. We're no longer in that environment. The VNA has helped us transition to a single PACS environment where all the data is accessible, searchable, and retrievable into those PACS tools, even though it was created generations ago in older PACS systems with different patient identifiers and so forth. So
that idea of the single view of the data, there's many systems across the organization that need to be able to access the imaging data that are able to, because of the VNA, go to one source for that imaging data and not have to talk to radiology to get theirs, not have to go to cardiology to get theirs, et cetera. So things like release of information, image exchange, or even burning the CDs, like Ken had mentioned, those processes to be able to pull, basically run a query against the VNA for a patient and get all of their imaging exams, whether it's in radiology or in cardiology or in sports med or neurology, that they're able to go to that one source, export all those images to that CD burner or to our image exchange network and get those set out. There's also the EHR wants to be able to index imaging exams. They're able to come right to the VNA to get that information about the imaging exams rather than going to all these separate departmental systems. There's like the patient portal. So again, kind of that EHR level of being able to allow the patient to see their imaging exams. They're able to hook that up to that kind of one imaging source as the VNA rather than all these separate imaging systems.
Awesome. That's a lot of information you guys have been hitting us with, and it's great. Barely scratching the surface on this, and we want to hear more for sure. So, for example, we talked about the intentions of the VNA was to, using standards-based processes to create this storage, and more than storage, as you guys have talked about, an active repository that was truly vendor neutral. But in your opinions, is the VNA truly vendor neutral, or is it sort of vendor neutral? Like, it may play at that, but is it a truly vendor neutral device? Brian, let's start with you.
Yeah, so we had touched a little bit on So DICOM is obviously the one piece that makes it vendor neutral. If it speaks DICOM, then any other system that speaks DICOM can talk to it, store to it, retrieve from it through the standard DICOM interfaces. And then there's DICOM Web, which is the newer option there, is be able to do the same sort of functions, store, query, retrieve through DICOM Web. And so that's kind of those standards based interfaces. The other piece of it, I guess, is so the HL7 is typically another standard that gets brought in. So if you're feeding like your imaging orders into the VNA so that you can validate exams against orders, all those types of workflows, being able to send HL7 notifications out to departmental systems. So like at Mayo, we have, when our cardiology system stores images into the VNA, they would like to get a notification back to one of their other systems with the basic information, the tags from those images that were stored. And so the VNA is able to send that standard HL7 notification back out that any system that's, again, supports the standards, the HL7 messages, and that they're able to communicate with the VNA. Between the DICOM and the HL7 standards, it's really about the vendor neutrality is the use of the standards for all the interfaces.
I would add, a lot of our customers have reminded me that, of course, they're still reliant on the vendor of the VNA. So it can't be all that vendor neutral from that perspective. And it's true that VNAs do have a long-lasting life if they're performing well. And hopefully those vendors are doing well. The fact of the matter is, though, that in addition to the DICOM standard, there are things that need to be considered and have been either barriers to or enablers of interoperability. So, for instance, Ken spoke earlier about the fact that they had 9 different PACS systems all storing to the VNA, but they couldn't yet share the data. A simple barrier to that was they had not yet found a common master patient index that could be used by all of those sites. And so without being able to correlate all of that patient data and use the same index effectively, it became a barrier. In other places that we've deployed our solution, particularly outside the United States, where we see a lot of regional implementations of VNAs because there's less competitive healthcare, it's more government-led healthcare, we will see things such as an XDS infrastructure already in place, which has a common master patient index across those sites. Or there will be a need to ensure standards of or not standards, but interoperability of certain clinical data. For instance, procedure codes, body parts, modality codes. All of those can vary between PACS systems or even hospital systems. So a particular hospital might use certain codes and another hospital uses a different set of codes. So how do you use the right codes? How does the VNA understand where it's sending the data and what it needs to present to that external system where it's sending the data, possibly a PACS, probably a PACS, with the right patient ID for that location, with the right procedure code, body part code, and modality code, for instance, that can be used by that site? Or does it need to present a different accession number? Does it need to send an order to that destination before it sends a study that that destination has never seen? So those are things that need to be considered when implementing a VNA. And those are things that we found out in working with our customers and have added to our product here at Fujifilm, of course, to make our solution not only DICOM compliant, but also be able to have that interoperability with the clinical differences and the simple fact of patient identification or session numbering needs at the various sites so that data can truly be interchanged.
Much appreciated. I'm going to ask perhaps a slightly provoking question, but if you don't mind me asking, so whenever you invent something, and obviously, the three of you have been around since the beginning here, if you look back at what the sound decisions were made when the VNA was born, is there anything you do differently?
I'll start just a little bit here because there's probably an interesting story here. So Greg and I go back to the beginning days, and their company formed to build a VNA for Mayo. It wasn't called a VNA, as I said at the time, but we had a decision to make, and the decision was around DICOM and non-DICOM data. So if you go back to 2000, as I mentioned at the start of this call, things were just going digital, right? And radiology was sort of at the top of the ladder, was starting that process. But there were other areas like photography, which the question was, do you skin the whole enchilada at once? And do you deal with all of the ologies like photography and cameras and DICOM? And if so, what do you do about all that non-DICOM sort of imaging that DICOM didn't really have a standard well defined for yet? It was still in the early stages. So we made a decision at that time to, all right, the first version of this thing is only going to do DICOM. And then we're going to circle back after we get this rocket off the ground and in orbit and working well and decide how we're going to deal with photography and maybe add capabilities for that. So now that question has been the buzz for 20 years now and still is the buzz in a lot of what do you do about photography and non-DICOM content? And so along the way, we decided, I guess, to use DICOM, encapsulate all of these photographs in DICOM, our videos as well that go on the VNA, and it has served us well. Other customers have not necessarily decided that, and I think Greg has probably been, from his company, in the perspective of how do we service both Mayo and these other customer needs. And I think all VNAs have had to deal with this. What do we do about the non-DICOM imaging? Do we treat it as a document, as part of a document management system? Do we create a special set of software to import those images and manage them with our own software? Or do we provide DICOM wrapping tools? I think that's been one of the still cruxes that the VNAs are dealing with. Most VNAs today provide some way to deal with that non-DICOM imaging, and many of those involve some kind of proprietary sort of a method for storing the formatting of the data, accessing, querying, and retrieving, and so forth. So I guess that's probably been one of the challenges. Greg, I don't know if you want to comment on that, because we did have a little bit of a divergence, I think, as time went along, and as TerraMedica started marketing their product to a broader audience, there were other needs and, about what kind of features and functions the VNA should have, some of which we used and some of which we didn't. But maybe you want to share some thoughts about that.
I think certainly there were challenges once you stepped out of the safe haven of DICOM, so to speak, and you moved into what we kind of call the wild, wild west of clinical imaging. And as Ken mentioned as well, there's a lot of documents. So where does a VNA fit in that picture has always been a challenge to figure out. And we ended up having to create a lot of different workflows and tools to operate outside of these departments that had well-defined workflows and tools, such as radiology. We just talked about how radiology and cardiology had well-defined packs, well-defined workflows. But if you step out of those departments, they don't typically have orders. They operate in a very ad hoc manner. And so how can you create a workflow where there is none? So we ended up having to build out a fair amount of workflow tools and capabilities. And then the decision is, how do you treat that data? Should you turn it into something that is in a standard like DICOM? Should you store it in DICOM? Or should you send it out in DICOM if it's needed? And so those are decisions that we struggled with and had to evolve our product to handle over time. I think we continue to have the evolution of our product to support more and more clinical specialties. And we've seen ophthalmology and endoscopy, urology, digital pathology. These are ones that are very top of mind in a lot of our customer base, dermatology. as well. We've had to add things to the product that maybe if we had known a little bit more before we started down that journey, we might have developed in a different way or a different path. But from my perspective, we're still solving the customer's needs today with the solution. And oftentimes it's the first time they've been able to actually have a little bit of a organized process and an organized index to their content. We walked in many sites that have quote unquote secure archive, and it consists of a drawer of SD cards from cameras. And nobody knows how to find anything, of course, and the security involves the lock on the drawer.
Great. That's awesome to kind of get an idea of how things could have been done differently. I always think about how the DICOM standard came about to some degree, and it provides a lot of flexibility, but at the same token, it's not so flexible that it doesn't actually give a standard or guidelines, right? So it's interesting to always hear when we talk about other standards, how they were designed and developed.
Simcast has been brought to you by the Society of Imaging Informatics in Medicine. Please visit our website at siim.org for more information and educational content, including webinars and an archive of prior episodes. Please follow us on Twitter at sim_tweets. Thank you to our listeners for your continued support.